This lesson is about calorimetry. So first we must know how to define heat capacity, specific heat capacity, and calculate heat change in two different systems. One is simple calorimeter, another one is boom calorimeter. Okay. Calorimetry actually is a method used in the laboratory to measure the heat change of a reaction. So measure the heat change of a reaction, and then apparatus is known as calorimeter. Okay, so there are two: simple calorimeter or boom calorimeter. Okay, so this is the example for simple calorimeter at constant pressure. Okay, so if you check your lab manual, right, actually experiment 2, we are going to do this simple calorimeter and determine the heat capacity. Okay, this one is boom calorimeter, so with electrical source. Okay, this one, the name is boom already, right, meaning that it's dangerous. So we have to take few precautions that when we conduct this experiment by using boom calorimeter. Okay, the constant pressure calorimeter, meaning that the outer styrofoam cup insulate the reaction mixture from a surrounding. It is assumed that no heat is lost to the surrounding. This is the assumption we assume. And then heat released by the reaction is absorbed by solution and the calorimeter. Okay, so when the reaction, for example, you make the hydrochloric acid and sodium hydroxide, so neutralization is happen, right? It will release the heat, and then the heat totally absorbed by the solution and the calorimeter. And then the function of the styrofoam outer the styrofoam cup, right, is to insulate the reaction mixture from the surrounding, so that we can explain there is no, okay, we can assume there is no heat is lost. Because maybe some explanation question might ask for this. And then this is the constant volume calorimeter. Okay, the volume is fixed inside the calorimeter. And then this outer one is the insulator container. Okay, here there are two important terms in calorimeter. The first one is specific heat capacity with small c, and then another one is heat capacity with capital C. The difference among these two definitions is one is specific 1 gram. Okay, another one just a given quantity. Both have to raise the temperature to 1 degree Celsius. So very simple to remember the definition. Amount of heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius, joule per gram per degree Celsius for specific heat capacity. And then heat capacity, okay, is the amount of heat required to raise the temperature of a given quantity, can be any quantity, of the substance by 1 degree Celsius. After that, another important part is the basic principle in calorimeter. We must always remember heat released by a reaction is equal to heat absorbed by surrounding. So there are few formula that we can apply to find out the heat of the reaction. So the heat is represented by the symbol of Q. Okay, Q equal to heat capacity times delta T. The delta T is the different temperature, means the final temperature minus the initial temperature. Or the heat might absorb by the water and calorimeter, and then in this case, Q equal to mass of water times the specific heat capacity of water times delta T plus heat capacity of the calorimeter times delta T. Or the heat just absorbed by the solution. Then it's mass of the water times the specific heat capacity of water times delta T. But actually, right, okay, the formula can be changed like this. Depends on the situation. So these are the probability of the formula. Depends on the question. Okay, so equal to heat absorbed by the solution, the heat absorbed by the calorimeter, the heat absorbed by the water and the calorimeter, or the heat absorbed by the water and calorimeter. And then if the mass of calorimeter is given, okay, and the heat capacity of the calorimeter is given. So another one, if we want to compare the heat released by hot substance and heat absorbed by the cold substance, we are using this MC delta equal to MC delta. Okay, over here, right, Madam want to emphasize you must understand the question first, and then check the information given by the question, then can help you to solve the problem. Okay, there are general steps in solving calorimeter problem, step 1 until step 5, and then the step can be interchanged, and then certain step might not be used for certain question. So this is just guideline. So first, balance chemical equation. Okay, because later next number of mole. These two very important because right, later you have to compare. So compare the number of mole by using the stoichiometry method. That's why if equation help you a lot. Okay, and then step 4, important formula. Of course, last one you have to answer the question accordingly and make conclusion. And then the final answer must be correct unit. So now we try few example. Okay, the first one. In an experiment, 0.1 hydrogen. Okay, very good. Because excess of oxygen, meaning that over here we no need to determine the limiting reactant. Hydrogen is the limiting reactant. And then the reaction is between hydrogen and oxygen produce water. So the step 1, write a balanced chemical equation. Okay, compress into 1 liter bowl and place into a calorimeter with heat capacity. Okay, so meaning that this is the heat capacity of the calorimeter. Okay, so meaning that C data is going to apply for this formula. And then the temperature of the solution was 25, finally increased 25.155. Okay, over here, this is the information for delta T. 25.155 minus 25. So now, question asks about calculate. Okay, calculate. Okay, calculate for what? Okay, calculate the amount of heat release. So amount of heat released in the reaction to form water. And then unit must in kilojoule per mole. Okay, so step 1, write down the equation. So over here, I know the number of mole is equal to 0.05 mole over molar mass. And then the formula that I'm going to apply is heat release equal to heat absorbed by the calorimeter by X mole of hydrogen. So over here, I know already it's 0.05. Q equal to C data. So you calculate everything. Over here is 0.05 mole of hydrogen. Okay. Will produce 14.074 kilojoule. Okay. Now the question asks about the formation of water. Over here is 1 mole. In this case, the number of mole of hydrogen is equivalent to the number of mole of water, 1 to 1. That's why we can straight away using the stoichiometry method to calculate the mole of the heat released by 1 mole of water. Okay, so stoichiometry to solve the problem. Okay, 1 times 14.074 divided by 0.05. And then you get the answer 281.48 kilojoule. So over here, the calculation, if you remain in kilojoule, it doesn't matter. But you have to make the conclusion. Heat of reaction. Okay, because this one is standard condition because kilojoule per mole. That's why enthalpy H with the sign equal to. Okay, this is about combustion. Enthalpy of combustion. So please remember must with the negative sign. Okay, must with the negative sign. Okay, your final answer should be negative 281 kilojoule per mole with the negative sign. Okay, mass with the correct unit because for this case the unit is kilojoule per mole. And then mass with negative sign because heat of combustion. Clear? Okay. So if we look at this diagram, right? Okay, so if we interpret in terms of diagram, so this is the calorimeter with the heat capacity. Okay, small c 9.08 times 10 to the power of 4 joule per degree Celsius, and then 0.1 gram of hydrogen over inside the calorimeter, and then the excess oxygen heat is released. So while heat is released, the difference is between this 25.155 minus 25. Okay. Now we look at example 2. Example 2, calculate the amount. Okay, so again calculate heat. Okay, and then calculate the keyword is have to calculate reaction in an aluminium calorimeter with mass. this is the mass of the calorimeter, meaning that we need to apply MC theta already. MC theta for the calorimeter. Okay, and then this is the mass of water. Okay, this is another information, mass of water. And then this is the delta T. This information is related with the delta T. So over here, specific heat capacity aluminum is given. So this is for blue color. I represent the blue color with the calorimeter. And then the green color with the water. This is the specific capacity for the water. Density is because we need to find the mass, not volume. That's why the relationship between density and water is what the density of water is 1 gram per mil. That's why the mass of the water actually is equal to 1,700 grams as well. And then this is the delta T. Okay, so you have to analyze the question first and then list out all the important information given by the question. Okay, if you try to transform the question into diagram, it's like this. Aluminium calorimeter, okay, with the specific heat capacity and the mass. And then reaction occur and then release the heat. So here we can get the delta T. And then inside here there is a water. So this is a mass of water. Okay, and then for this case, actually it's quite simple. We no need to find out the formula, write out the equation. We straight away apply the formula. Okay, heat released by this reaction equal to heat absorbed by aluminium calorimeter and heat absorbed by water. So this statement compulsory. Class, madam, now tell you all, this statement compulsory, then only go for the formula. Okay? Why madam insists you all write down this one? Because you can make yourself clear. The heat of the reaction is absorbed by what? By the solution? Or by the calorimeter? Or by both? Or there are two solutions? If you can write down this, should no problem for you to get the correct formula and then substitute everything and then get the answer. So the heat release for this case is 25 kilojoule. So meaning that for this question, there is no step 1, step 2, step 4, and step 5. You straight away identify the heat change, then choose a formula. Okay. Next, exercise 1. The heat of neutralization for the following reaction is negative 56.2 kilojoule per mole. This information is very important because this is heat of neutralized. If you notice, right, the unit is kilojoule per mole, meaning that, okay, if you still remember the definition of enthalpy of neutralization, is referred to water, okay, is referred to water, and then the unit is kilojoule per mole, meaning that the formation of 1 mole water equal to 56.2 kilojoule. That's why you must understand the question, the information given by the question. And then equation is given, so step 1 is done. Write a balanced chemical equation. Okay, now we check for the question. 100 ml and then 1.5 molar HCl mixed with 100 ml 1.5 molar sodium hydroxide. Okay, so in this case, actually it's safe. Why? Because we must check which one is the limiting reactant first. Since the volume and the concentration of both reactant is the same, meaning that they can react completely. Okay, so the number of mole, no problem. By using mv per thousand, we can find the number of mole of this of the sodium hydroxide and hydrochloric acid. Once we know the number of mole of this reactant, then we can know the number of mole of water as well. And then in a calorimeter having a heat capacity, so this is another information. So calorimeter is the heat capacity of calorimeter is given. Initial temperature, okay, 23. Okay, this is the initial temperature, okay, 23. Okay, then question asks about calculate. Okay, just now is calculate about heat, now is calculate the temperature. Calculate the final temperature. Okay, be careful. The question asks about final temperature. Sometimes, right, the question asks about the change of temperature. So be careful. Over here, what are you going to do? Okay, of course, you must understand the question first. Okay, so this is the simple calorimeter. There are two solutions, meaning that the mass of the solution is 200 ml, means equal to 200 gram, because the density is 1 gram per ml. And then the heat capacity is specific heat capacity of the solution is given, and then the heat capacity of the calorimeter is given. So meaning that the heat released for this reaction is absorbed by the calorimeter and absorbed by the solution. Okay, and then now the question asks about the final T. Okay, let's check the answer. Yeah, step 1 done, formula, equation. Step 2 now is formula. And then you have to compare by using stoichiometry method. Okay, just like I told you already, right? 1 mole of water form equal to negative 52.6, right? Now, the number of mole based on this question is 0.15 mole. So the heat released by this question is negative 8.43 kilojoule. Okay, and then now the question asks about, okay, temperature, final temperature. Okay, so this formula we are going to use. Madam told you already, right? Okay, something missing here. Who can tell me what is the missing part? Yes, you have to write down. Must write down, okay? The solution in your lecture note something missing. Okay, you must add now. Okay, must, heat released by the reaction equal to heat absorbed by the calorimeter plus heat absorbed by the solution. You must write down this so that can help you to choose a correct formula, substitution, and final answer. Now you know the delta T is 9.904 degrees Celsius. Okay, the question not ask about the difference, it's just about the final. So initial 23.2, so you sum up the difference, so the final temperature is 33.1, don't forget degrees Celsius. Clear? Okay, exercise 2. Okay, a calorimeter contains 400 ml of water. So analyze first 400 ml of water and then 25 degrees Celsius. And then another 600 ml of water. Okay, at 60 degrees Celsius. Is added. Okay, now to determine the final temperature. Now the question asks about the final temperature. So final temperature, assume that the heat absorbed by calorimeter is negligible. So over here, right, meaning that when both solution mix together, okay, so the 25 degrees Celsius might increase, and then the 60 degrees Celsius solution might decrease. So meaning that we are comparing MC theta equal to MC theta. Okay, look at here. So 425, 660 mixed together. So what is the final temperature over the solution? Okay, we are going to apply this formula. Heat released by added water equal to heat absorbed by water. So MC theta equal to MC theta. The C for both solutions is the same, can cancel off. So now, okay, we have to know the first one, the delta T for the first one is 60 minus Y. And then for the delta T for the second one is Y minus 25 degrees Celsius. Okay, so this one is very important. Okay, why? Because, okay, the final is 60, and then how about the Y? Okay, this one the final is 25. How about the initial? So once you substitute, okay, you can find out the value of Y. Okay, just mathematical over here. After the few example, right now is your time to check your understanding. There are 6 questions in your tutorial. It's related with calorimetry. So please try it by yourself. Let them give you some hints. Okay, follow the 5-step. Okay, 5-step method. And you check the information that be given by the question. Okay, for example, specific heat given by the question, meaning that we need to apply it. Okay, and then if the specific heat, the heat capacity is this information is referred to 1 mole. Okay, 1 mole of methane release negative 890 kilojoule. So you must clear the you must understand the question and analyze the question, then you can answer it. Final answer will be given by Madam later. Okay, enjoy your weekend by this exercise.